So, thank you very much for inviting me as well. It's really interesting to be jumping into the metaverse and discussing these timely topics. I suppose, like many speakers, I want to start out with what is the metaverse right now. It feels like a bit of a marketing term. Every time I Google the metaverse, I say the perception of these virtual worlds, things that we haven't really built yet in a consistent way to say that a person will believe they're in the metaverse when they're in the metaverse, similar to augmented and virtual reality a couple of years ago. And I think that's important because many people have expectations about what a technology or what a product or what an experience is going to be. And the metaverse is still very amorphous and undefined. When I think about the metaverse, it's actually quite in line, I think, with what I've heard from some of the other talks. I think of the metaverse as, first of all, shared worlds. Shared meaning that we can move physically from one world to another, whether we're moving from a sim to the sandbox, for example, much the way that we move from one world to another in real life. Key point, I think, though, is the control of your identity, as has also been brought up. Interoperability is the ability to go from one world to another and take all your stuff with you, right? If you have avatars, if you have tokens, devices, the ability to have a digital object which can move with you from one metaverse to another, that also really underpins what I think about when I think about the potential for metaverse. And these are being enabled by many, I believe, of the technologies that are coming up in the world, crypto, NFTs, maintaining your identity, maintaining uniqueness in a digital world, and going beyond the idea that everything digital is only going to be a copy of itself. So that's really what I think about when I think about metaverse. And then the other thing is, of course, interaction. How do we really expect ourselves to be interacting in digital worlds? So to give you a little bit of background on myself, I work quite a bit with wearable sensors, neurotechnology, data, and product development. So when I think about how we can characterize ourselves as a digital entity, I think about sensors that are understanding how we want to interact with the digital world. That could be wearable sensors, that could be heart rate sensors, that could be sensors that are trying to understand our emotional state at a particular point in time, then interpreting those states and then taking an action. And I think really what's interesting is the idea of a metaverse which has autonomy, which is understanding us more as a person, as opposed to just being programmed to take a certain action when I do a certain interaction in the metaverse. Now, because the metaverse was coming up with this idea of popularization through Facebook, the concept of virtual reality, I often love to look back at how we've been conceptualizing interaction beyond just physical, tangible touch. We've been trying to do this literally for decades, going from the immersion of our senses in different environments to bringing it to something which can scale. And I think the metaverse also has scalability as a critical foundation, because if we're tied to one virtual reality experience in one specific game, and we can't transfer our identity and our person to another game, then I don't think it's really fulfilling the vision of what we think the metaverse can be. And right now, whenever the metaverse comes up, we think about avatars, people being able to change their identity, as we said before, fluid identity, fluid ability to represent yourself in the way which you want to represent yourself, beyond the physical person that you are. But one of the things that I haven't heard too much about is how do we represent our emotional selves? How do we communicate emotion in the metaverse? Because right now, we have this long vision of digital avatars that are somehow acting exactly like us. But how do those avatars actually get that information? How does an avatar know that I'm happy or sad? How does it know if I'm smiling or frowning? Now, there's certainly different ways to do that, right? We can use machine vision to extract what a person is doing in real life, if they're really smiling or really frowning. But I haven't heard a whole lot of information about how that's really going to happen, because many of the interaction mechanics that we have from the metaverse are still first coming from our traditional concept of what a computer is. A mouse and a keyboard is what many people from my generation have grown up with. The next generation has been growing up with mobile touch devices. So the ability to touch, point, and zoom is how many people think of interacting with a computer. And if we start to go and use virtual reality technologies, then we start to open up the possibility for example, gaze direction, looking one way, and then having an environment change its behavior, interacting with things in a 3D world, but still having the issue where we might not have actual tangible feeling when we're trying to touch something in a virtual world. And I think we're making great progress in understanding better how to interact with the virtual environment. But what I'm working on personally is how we work with information coming from the brain. And the brain is really an interesting thing because we're interacting with our brain. Our brain is processing all the information that we're taking in around our physical world and also our virtual metaverse worlds, right? So when you have visual information coming into your eyes, you're recognizing objects, you're throwing out a lot of information because our brain can only process so much information. When we're walking, when we're touching, we're interacting in so many unique ways with the world that we do not realize it. Because if we had to control and keep track of every little way that our body moves, it would basically overload us. And so we have our subconscious and we have different control mechanisms in our brain which take over all these different experiences. And one of the big things that I see coming up, and also one of the things that we could be scared of if we think about the anti-hype or the negative effects of metaverse, is the neuro part. So many people will probably understand what a brain is. Probably many people have not dissected a brain. I also have not looked at my own brain. And that's one of the interesting things. It's one of the most critical parts of our body, and we can't really look at it, right? We can understand the effects that it has on us. We can change its performance with things like meditation, but it's still, to a very extent, a black box. We do have different imaging techniques to understand our brains. So, for example, we can use the electrical potentials of our brain to understand how our brain waves are changing over time and with different environmental stimuli. We also have really advanced imaging technologies like magnetic resonance imaging or different light-based systems, which try and see how oxygenation in your brain is changing, and then we try to relate that to brain activity. And in the metaverse, a lot of the ways that we can understand what's happening in the brain and then connect it to the connected world is first probably going to be through EEG. So EEG is based on a technology where we put electrodes onto our head, we measure the small biopotentials of our scalp, and those are all coming from our brain. Our brain operates on different wavelengths, and depending on how we capture that activity, we can understand different things about a person. We can think about, for example, how your emotional state is changing. And we can also really tie that to identity, because different brainwaves from people can also be used to identify them, much the same way that different heart rates can be used to identify a person. And if we think about how we will eventually have a lot of information about biological sensors that could be capturing all this information about us, we have to find ways to scale it, to collect it. So, for example, there's a new initiative coming out from an organization called Lynx from phase3.io, where they want to build a crypto wallet, which is essentially going to be pulling in a lot of information from wearable sensors. And the idea is that each person can then control that digital data part of their identity and then share it with other connected devices. And this I see as one of the really cool things, because you don't always know what your brain is doing, right? If you can share your neuromarkers or your biological markers of your brain and use that as a thing that can be transferred in the metaverse, that can be a way to help share what your emotion is. That can be a way to help share what your performance is. And it's something that I haven't really heard talked about too much yet. It also has a lot of negative connotations, right? If I'm watching different movies on Facebook and Facebook understands the media that arouses me the most, it could be a way to start to hijack my brain for different marketing purposes. So when we're building the Neuroverse or neurotechnology into the metaverse, it's also critical that we think about the security, because this is some of the most personal data that you have about yourself. Now, to give you a little bit of a fast education on how brain-computer interfaces work, traditionally BCIs will capture biopotential activity of your brain. This biopotential activity is basically created from little neurons that are firing inside your brain. And when we have collections of neurons in different brain regions all firing at the same time, then we can pick up this information using electroencephalography. And this is basically just saying that we're capturing the small biopotential signals at the top of your brain. Now, this technology is still in a developing state. So one of the big challenges that we have in brain-computer interface design is building electrodes that are comfortable and can actually integrate very well with different product designs. So you can imagine if you have a brain-computer interface on your head and you also have a lot of electrodes, it can be uncomfortable. But there are companies like OpenBCI that are currently working with companies like Valve to develop brain-computer interfaces which are comfortable to wear and also really designed together with a VR technology. And when we measure what's happening in the brain, you can think about it like having a sport watch, which is measuring how many steps you're taking, right? We basically look at the change in brain waves of your brain, and we connect it to things that are happening in the environment. Now, these neuromarkers have been characterized for some very specific things. For sleep, for example, we understand how your brainwave is supposed to change when you fall asleep. We don't necessarily understand exactly how your brain, in your individual brain, is going to react to different emotional stimuli like images and movies and music. But I see the potential for building systems which will autonomously learn how you react to different stimuli and can build models to basically help you interact with the world. So many BCI devices are focused on collecting the data from the scalp, meaning we have electrodes which are going to measure from the forehead or from the top of the head. And these are there because they focus on different brain regions. For example, the motor cortex in the back is going to be focused on how you interact physically with a game controller. A lot of things like focus or sleep, it'll probably make a lot more sense to collect it from the forehead. And we've started to also work with different ways to understand how our brainwaves is going to interact with the environment. So for example, if we control a generative animation just using forehead electrodes. This was a project which was done where Mayank, he's currently also working on developing generative art for NFT collections. The animation is going to change based on his focus activity, which was collected from his forehead, and it's basically understanding how his brainwave is shifting and changing when he closes his eyes. So we have a lot of the building blocks, the components for this. And I keep thinking, okay, so if we have this in the metaverse, this potentially means that if I have a system which can track my emotions, it means I now have the agency to allow that emotion to be shared with the people around me or not shared. It's interesting because in real life, there are people who can mask their emotions. There are people who can't mask their emotions, right? And a person who can't mask their emotions might want to do that in real life, but they don't actually have the ability. But in the metaverse, it's now they actually have that control. And I think it's really interesting to think about these biological and physiological processes that we have, which we don't have a lot of control over sharing in real life. And we do have control over it in the metaverse. Coming back to a bit of the product design, a lot of the work that I do right now is focused on understanding how we can use technology like hearables, earbuds that are currently evolving to not just deliver music, but to actually also understand your biometrics, be it heart rate or also your brain activity. And the great thing is that instead of focusing on devices which are rather bulky and collecting data from the forehead, we can now integrate it into earbuds. The cool thing about integrating into earbuds is that the headphone for the metaverse is, I think, going to be a much more important interaction device in the future, right? When you can control and you can understand the voice of a person, you can also understand if they sound stressed or full of anxiety or happy. It's another way to capture information about the person. And what we've been developing are brain-computer interfaces which measure brain activity from inside the ear canal. And if we can do this, then it basically means that we can create devices which are just integrating with the normal devices that we use in society every day. When we had devices like Google Glass come on the market, the problem was that they're not a device which people were already using, that already were accepted and loved by people in society. But earbuds, on the other hand, are devices which hundreds of millions of people use every day. And our goal is really to explore how we can connect the cognitive and emotional intelligence of a person to the connected world and the metaverse. And the full way that we conceptualize this is what we call the neurofeedback loop. So when we build brain-computer interfaces, we first collect brain signals. We then have to clean those signals. We process them. And then we try to extract neuromarkers, which basically means that if you're in a game environment and you're feeling stressed, for example, we want to understand how you personally and your brain is personally changing when you're feeling stressed. If we can then connect that up through APIs to the environmental influence or the environmental information coming from a VR world, for example, then we can set up a system where that world is adapting to your cognitive and emotional needs. And it's super exciting because right now, whenever we interact with a digital product, it's a very direct interaction, right? If I click on my computer, I know exactly that I'm clicking on a very specific button. I know that I'm using my mouse in a very specific way. And with neurotechnology, we're opening up the possibility for controlling the world subconsciously to a certain extent. So one of the devices that I'm working on right now, we allow ourselves to collect brain data. We bring it up to a cloud platform so that we can then extract neuromarkers through our API. And now we're thinking about ways for how we can essentially connect this to different digital worlds and to the metaverse in the future. And this idea of, let's say, the Internet of Humans, as some people would like to call it, we're building it as a way to build a better bridge between humans and the connected world. And if we do it first at a development kit level and then bring it into greater product development, we're essentially exploring this new interaction pattern. So for example, if you're in the real world and you can control your lights through your mind, meaning that you walk into your room, you're tired, you want to fall asleep faster. If your room understands what you need and can adapt to you, we basically build a way to have a more inclusive life. And doing this in the metaverse just opens up a plethora of opportunities. Because if I can do it through an API and I don't have to connect every time to a physical device, it means I can create these new product experiences that, even though they might be possible in the real world, they're not as adaptable and they're not as scalable. Also, concepts like meditation. When we've thought about the metaverse and sometimes mindfulness and meditation experiences, I've sometimes felt let down by them because I don't feel that the meditation experiences in virtual reality have really used the potential of the connected world. You know, many times we try to too accurately just duplicate the reality in a metaverse or in a connected world. And we should really always think beyond that, right? Think about not necessarily just duplicating an interaction, but rethinking what an interaction could or should be. It's going to be a long road to really bring neurotechnology into the metaverse because right now we're still quite focused on proving the technology. But there are many companies where we're moving from doing the validation of the technology to building new experiences through APIs, and really interested in looking to connect with other people and understand how we can build this type of inclusive metaverse together. So I basically just wanted to give you a view of neurotechnology, what it is, how it can be integrated, and try to open up dialogue on what this could be for the metaverse in the future. Also consider that neuroethics is a really big topic. We don't want to misuse people's brain data. We only want to bring a more inclusive experience. So let's say thank you very much. Hope you enjoyed this intro, and we're very happy to connect and share conversations in the future.